Hello. This is the first video I've made in my new recording studio, if you can call it that. And I'm just making it really to say hello and show you what we can do for you in terms of making videos. This is one made in my own home, so yeah, we'll find out how this goes. I thought I'd just pick a question because I'm going to pick it from Ex3F, which is the rates of change exercise. So I haven't talked much about that because it was a homework, and I noticed some of you working through that, and some of you I'm not quite sure what you were doing there. So let's get on with it. Right. Okay. So the question we're doing, this one, about the sea and the hill and the lake. So it gives us an equation which describes the profile, the land profile, if you like. And the first question is asking us, find where the lake is located relative to the shore sea line. I'm just going to answer that one verbally, because hopefully you realise that the x is represented here by the x-intercept here, and then your lake must be at 2 and 3 kilometers. So the lake's 2 kilometers away from the shoreline, and it's a kilometer wide. And that's really all there is to that. So if we go on to B, which is about finding dy dx. Now, if I write pretty small, I'll get most of this question on, but it is a bit of a squeeze. So dy dx. In fact, before we go finding dy dx, what we really should do is multiply out these brackets, because otherwise we're going to end up in a bit of a mess, because we've got 3 factors. So let's get rid of, let's multiply these 2 out first. We won't bother with the kilometers, and then we'll multiply through the 1/10 x, so 1/10 x cubed minus a half x squared, and then plus 3/5 x. Okay, now we'll differentiate because it's easy. So therefore, dy dx is equal to 3/10 x squared minus x plus 3/5. Might be a good idea. Well, we'll let it equal dy. We'll let dy dx equal 0. Let's go back over to the question. What did it say? Find dy dx and interprets its value. Oh, we've got to do that part. So I'm going to pause the video on this part here and just write the solution. Just a sec. Okay, to find the answers for, or interpret what's going on here, I just substituted a half and 1.5 into the equation I just found over here, and you can see the working out on the calculator just here. So here's your 3/10 x squared minus x plus 3/5, and I get the 2 solutions, 0.175 and negative 0.225. So what you're getting there is the slope here, and the 0.175 is the slope here of the hill, okay, and then the negative will be on this side, about 1.5. So that's what's happening there. So that's how to answer that question. So I'll get into the meat of the question really, and we'll just look at C. Alright, so we're going to let dy dx equals 0. Okay, so this is really C, and I didn't really finish off B properly, but anyway. It would probably be, or save us a little bit of time, just over on our calculator. We multiplied everything through by 10, so we got 3x squared minus 10x plus 6, and so we can then solve our quadratic equation. So back over to the calculator, I'll just go, I did this earlier actually because it's the second time I made this. We go over to equation, polynomial, degree 2 because it's a quadratic, and then you can see like 3, negative 10, and 6. I hope that's a 6 is already there. And so we get two pretty weird numbers, 2.5485, 2.5485, and 0.7847. 0.7847. Okay, of course, they're the two stationary points. Yeah, the top of the hill and the bottom of the lake. So we were going up, down, up, and this is I've called it. Yeah, it is Y, isn't it? This is the sign diagram for dy dx. So it said find the deepest point of the lake. Well, that's where the deepest point of the lake is. Okay, you've then got to substitute this. So that's the x value for the deepest point. I'll just look at the screen. You can't see it if I write like that. So x value for deepest point. Okay, so we'll have to sub that number all the way back into there. Well, that will be annoying as well, so I'll pause the video, I'll put it back in, and then we'll get the depth of the lake. Okay, so I went back to my calculator and I typed in 2.5485 back into the equation. You can see it there, or you can see a bit of it, and I got the answer negative 0.6. Negative 0.66063, can't say it. I'm expecting a negative number because it's below the x-axis and it's in kilometers, so that represents 63 meters. Okay, so it's 63 meters deep, 63.1. All right, okay, bye.